Hey guys, I am Gideon of Benco Institute of Technical Studies, your very popular small engine channel. Well, on today's class, we'll be looking at a very portable lithium generator, a petrol generator. Well, this generator is for a client of ours. She called us some time ago and told us she was actually using her generator in her house to power some of her household appliances. And all of a sudden, the power went off. Though the gen was still running, but you know, when your power is off, that certainly means you can't use your gen. And of course, for that reason, we brought it to our base where we'll be looking at the gen critically to see what exactly is the fault. Well, we'll be teaching today on the different tests to carry out. You do not just see a generator which have power issues and you think, okay, I need to fix this, or you work based on assumptions. No, we won't do that. We'll be teaching you the various tests you need to carry out for the generator to come back to life. Well, in this particular class, for the first time, we'll be doing this. We'll be teaching both theoretical and the practical. When I mean the theoretical, we'll be writing on our board, trying to explain in details what the test is. And then, of course, we'll go to the practical, which you know the channel so well for. We'll be dissecting the generator, opening and seeing, and replacing and fixing, as the case may be, what is wrong with it. Without further ado, let's dive into the theoretical class. To restore power output in a generator, there are some very key tests one needs to carry out. One of them is the eye test or the vision test. This involves scanning your generator for possible faults. Number two is the continuity test. Continuity test. This test involves using your multimeter to check for discontinuity. Well, we'll delve very deep into that when we touch a generator. Number three is the voltage test. This involves using your testing lamp or using your multimeter to determine if there's voltage in the generator. Number four is the brush test, also called the carbon brush test. This involves testing your brush. Number five is the alternator test. And for this alternator, we'll be looking at two very key components, the rotor and the starter. I will be performing individual tests on them. So therefore, we have the rotor test and we have the starter test. Without wasting much time, let's delve into the practical class. Alright, this is our lithium generator. This generator, like I said earlier, couldn't give out power. Well, in the theoretical class, I said the first thing we do when we get access to a generator like this that doesn't produce voltage is to perform the eye test or the vision test. And this is it. When you have a generator like this, and perhaps you really want to fix it yourself, yeah. After watching this video, I expect you to be able to fix a generator like this yourself. You really want to fix. The first thing to do is to look at these sockets. Okay, you look critically at these sockets. Look internally to see if there's burn anywhere. Is it heated up? Is that burn anywhere? If it's heated up, that means there's a possibility that the wire that connects down to this has been disconnected because of burn. It's very possible. But looking at this particularly, there is nothing like that. The socket is very much intact. Next up our sleeve is the continuity test. And this is our multimeter. We will make use of the analog multimeter here. Okay. For some multimeter, there is almost a diode symbol that talks about multimeter, that talks about continuity. Yeah. With that, you easily check for continuity, something like a diode symbol. But for this particular multimeter we are using, there is nothing like diode symbol, and for that reason we'll be using the resistance. Okay. All right, just to check if the multimeter is working. You see? Okay. I've just noticed something. I think for other multimeters where you have a diode symbol, this doesn't have a diode symbol, but it has it's, if you check carefully, it shows boost. Okay, this shows that a machine is continuous. All right, let's check this machine. Oh, okay, inserting the probe into, if you insert the probe into the positive and the negative, of course there is no polarity. Since the generator is off, there is no polarity. Okay, you check, looking at the meter, what does that show you? There is continuity, right? We succeeded in confirming that this particular socket is continuous. Let's go straight to the other socket. Okay, we've succeeded again in confirming that these both sockets are very much intact. They are very continuous. What do we do next? We do the voltage test. That is the third key test we have to work on. We do the voltage test where we can use the multimeter and use our test lamp. Let's use our test lamp for this. Okay, what I'll be doing now, I'll be putting the generator on and inserting my test lamp. And okay, let me kickstart it first so you. All right, what I just did was to check if our test lamp, when directly connected to this socket, can produce light. You bring voltage, but it turns out it didn't. And again, before I continue, another part of the eye test is this: when you put on a generator, when you know your generator is very much functional, and of course before now the voltmeter on the generator's dashboard works perfectly, but this time around when you put on the generator, use your eye to confirm if there's a reading here. If there's a reading here, you know you have to look for something else to work on, and certainly with other tests you'll be able to detect that. But for this particular machine, there is no reading here, so we go further with our fourth test, and that is the brush test. So just a recap, we've done 3 tests on the generator already. We've done a visual test, we've done the continuity test, we've done the voltage test, and now we're looking at the brush test. The brush test is found, the brush rather, is found at the edge of the alternator. Okay, I will lose the alternator so you see it. Do not forget, while you lose, make sure your bolt is kept properly. Okay, this is the brush. Visually looking at the brush looks very much okay, but we're still just going to test the brush. We're still going to confirm if the brush is okay. Okay, what do we test for in the brush? We test for continuity as well. Okay, we'll test for continuity. We check if it reads. If it reads, that shows the brush is coming. trying to, if you notice carefully, I'm trying to get a particular spot where it's going to. Okay, but if you notice carefully, it's reading. What this shows is the brush is very much okay. Let's take off the brush, and looking at it, we can view it physically to confirm if it's very much okay. You see the two legs are still very intact. This gives the brush its name basically. This is carbon, made of carbon, and it's called carbon brush. I think that's even the reason it's called carbon brush. Okay, we're done with the carbon brush test, and we'll confirm that the carbon brush is okay. What other test do we do now? Okay, if you go back to the theoretical explanation via the whiteboard, we said we'll be looking at the alternator. Up next is the alternator test. The alternator is made up of two parts. The alternator is made up of two parts. We have the rotor, which is this. It rotates. The reason it's called the rotor is because it rotates. If you, okay, I just hope you notice that it rotates. That's the rotor, it rotates. And this is the stator. The static part of it is the stator. The stator does not rotate. Where the stator is fixed, the rotor rotates. And the rotor is also called the armature winding. The stator, therefore, is called the field winding. All right, let's test for the armature. You see, what we just did now, what we are doing now is this. Okay, before I continue, please. This is the commutator or slip rings. Let's call it slip ring. This is the slip ring. Okay, the slip rings. This is the particular ring where this sits on, where the brush sits on. So that's what we'll be testing. Please make sure you show them the meter as well. While I'm testing this, let them see the meter. Okay. Okay, if you notice, it shows that the wires, the field wires, are very much intact. So what have we done so far? We've done different tests, and we are now in the alternator, and we have done the alternator test. In fact, the alternator test is basically the easiest. You just test to see if it's continuous. All right, let's test the stator, the field windings. Okay, these two wires, unfortunately this generator is quite old, so stuff here has been amended, but I will try to explain in details how you can locate the wires to test. These two wires are coming directly from the stator, from the static part of the generator. So what do? You test as well. You see? It shows the wires are very much intact. They are very much continuous. Now we've done 5 different tests on this generator, and we've been able to test every other thing to see if they are the reason the generator is not producing voltage. And fortunately for us, the generator, the alternator is okay, the starter rotor is okay, the dashboard is okay, everything is intact but the AVR. Okay, basically for most generators, when you observe your generator does not produce voltage, one of the main reasons it doesn't produce voltage most times is the AVR. And we can see this AVR is quite old and there is need to change. All right, we equally have another AVR with us here. In fact, we have multiple AVRs with us here, but we're going to try this out. This was gotten from another machine. We'll try this out before coupling. Okay, this goes to the brush, so we have to fix the brush. We have to fix the brush, and we have to fix it appropriately. Okay, it's easier to lose than to fix, you get. So after losing, make sure you fix it properly. You see what I did just now? While fixing it, I had to use a finger of mine to press it down. What am I doing? To make sure it connects with the slip ring very, very well. All right, it's connected now. So what do we do next? Okay, the left hand side of the brush is the positive side, and we'll connect this positive side of the AVR to the left hand side, and this negative side, of course, if here is positive, here is negative, goes to the other end of the brush. So after doing this now, we are going to put on our generator and run the test we've done before to see if it's back to its normal chip. All right, I know you saw what happened just now. Our generator is back, and what we've done is we just changed the AVR after performing other tests, and the generator is back. If you notice very well, this voltmeter was able to read, and in fact there was, okay, let me put it on so you notice if you didn't notice the first. All right, our voltmeter read, and of course our test lamp was able to give us a light, and that is it. Basically, we've been able to fix a generator that couldn't produce voltage for our client. Okay, let's couple back. After fixing, the best thing to do is to couple. You quickly run through the coupling. Originally, I would have used an L spanner here, a longer spanner that would have allowed me, giving me the leverage to just tie this with ease. But in the absence of that, I am making use of this spanner. But notwithstanding, it has done its job, albeit a little bit slower. Alright guys, that is it from an end. Till meet in our next class. It's goodbye from us.